We're live now. Hello, everybody. I think you can see and hear me. Welcome to the AltaSea webinar, one of a series of spectacular webinars that teach young people and people of all ages more about our oceans and the amazing people that are studying our oceans and doing as much as they can. We hope to sustain them and make them more sustainable. So AltaSea, first I should introduce myself. My name is Zavala, and I spent 30 years at KCET Public Television as a journalist and news executive. And I am now retired and loving it and very interested in the environment, which is one of the reasons why I hooked up with AltaSea. And I'm very, very pleased to be moderating these webinars. So AltaSea, if you don't know, is an enterprise. I'm going to read a little bit here. Located at the Port of Los Angeles, it is dedicated to accelerating scientific collaboration and advancing the blue economy, ocean economy, through business innovation and job creation. It also aims to inspire the next generation of ocean lovers who will help develop solutions to challenges such as climate change, energy supply, and global food security, all of which are very connected to and dependent upon a healthy and living ocean. Now, before we meet our panelists, let me encourage all of you to listen, to ask questions, and simply put your questions in the chat box. And then Jacob, who is moderating, or who is handling this behind the scenes, will text me your questions, and we will really try to get to as many of them as possible, because your questions are much more valuable than mine, because you are the ones that want to know and learn from these amazing women we have today. And they are, we will begin by introducing Laura Lilly. Laura Lilly is a 6-year Ph.D. candidate in biological oceanography at the Scripps Institution of Oceanography. She researches how El Niño events impact the zooplankton community of California. Lilly is a seagoing oceanographer. She has gone on several month-long, maybe even multi-month-long sailing trips across the Equatorial Pacific. Lilly is passionate about sustainability and conservation and has served for the past 4 years as the co-founder and co-leader of the Scripps Sustainability Group, which brings more sustainable practices to Scripps and UCSD. She believes strongly in getting young people excited about oceanography and has developed and taught short introductions to oceanography at several high schools around San Diego County. Welcome so much. Also with us, Sarah Maher. Sarah received a Bachelor of Science in Physics and Astronomy at the University of Victoria in Canada. She has a Master's in Geology and Geophysics from the University of Hawaii and Manao, and she has worked on plate tectonic reconstructions. She is currently a 6-year Earth Science PhD student at Scripps Institution of Oceanography. Her research looks into using magnetic techniques to examine how the ocean crust cools. This involves month-long cruises off the coast of, included a month-long cruise off the coast of Easter Island, which is way off the coast of Chile. And there she collected magnetic and bathymetry, which is, I've learned that what that word means. It means the topography of the ocean floor, seafloor. So she collected data about the topography of the seafloor and rock samples. She also helped design a 10-day cruise to the Fieberling Seamont chain, which is about 500 miles off the coast of San Diego. She and her colleagues went on this cruise where graduate students learned geoscience methods at sea. Also with us as our third panelist, Camille Pagniello. Camille is a 6-year, they're all 6 years, so there are cohorts. 6-year PhD student majoring in applied ocean sciences at Scripps Institution of Oceanography. Camille thinks of herself as part marine biologist, part physicist, part engineer. Her research interests lie at the intersection of acoustics and geophysics, robotics, marine animals, and sustainable management. She is currently using passive acoustics, she'll explain what that is, and optical imaging to identify the sounds of certain fish species and to locate their spawning areas. She spent over 80 days at sea, including time as chief scientist of the Kelp Acoustics Propagation Experiment, an experiment where she designed as a graduate student. Her goal is to advance the understanding of ocean processes and further conservation efforts. So those are our amazing panelists, and I know you'll have a lot of questions for them, but I will start off our conversation. And we'll just start, I'll just kind of go sort of clockwise. I'll start with Sarah. Tell us a little bit more about your research. I just mentioned it so briefly, but if you can give us a little better, each of you actually will go around, give us a little better idea of what you actually do and how you hope, what you hope the results will be and how that will advance oceanography and hopefully the ocean sustainability. We'll begin with Sarah and then go to Camille and Laura. Sarah?
Yeah. Sorry, let me know if there's feedback or anything. Yeah, I use magnetic techniques to kind of look at how the ocean floor cools, which I think is really interesting. One of the things that really interested me about the ocean floor in general is that plate tectonic reconstructions are such a really recent scientific endeavor that it's only 50 years old. We didn't know how the Earth was forming and how plates are moving apart, and magnetics was a huge thing that really let us know how our Earth works in a lot of ways. So I was really interested in that, and I actually came on board at Scripps for this really cool project that lets us look at how the ocean floor cools. And the way we did that was we looked at this giant, I guess you'd almost call it a hole in the ocean floor. It's a rift that happened, and it exposed these really deep rocks. And we got to go and take these kind of machines here where we're looking at these really deep exposures in ocean crust. And we get the chance to actually take these rocks from the bottom of the seafloor and look at how they're oriented in space. And
you mean you bring them up to the boat?
Yeah, so what you can see behind us is there's this tool that's actually measuring the strike and dip, basically how a rock is oriented in space. And so we know how it's oriented, and once we grab the rock, we can take it and orient it back.
Oh my God.
Yeah, and so we're looking at the magnetic field. So I think everybody knows we have an Earth's magnetic field.
Yep.
It points north right now, but it actually has flipped over time. So while it's north now, it was south in the past. And that's actually
way in the past, right?
Yeah, well, it depends. It actually flips pretty infrequently, and it tells us how, like every 10,000 years or so, it tells us how, it gives us an estimate of the age of the seafloor. And we can use that to kind of tell where we are in time and reconstruct what's going on. So by grabbing a rock and knowing how it's oriented, we can look at the magnetic minerals in it. And if they're all pointed north, we know it's a certain time. And if it's pointed south, we know it's a different time than that. So we're actually looking at really interesting kind of rocks. Before we went here, we had less of this kind of rock than we had moon rocks. And now we have over 2 tons of rocks for me to look at and investigate. So it's been a really cool endeavor, and I just think it's really interesting. It's kind of the forefront of science. We know a lot about the ocean, but there's still so many mysteries. We don't know how things are forming in the very bottom of the ocean floor. So I think it's really cool to kind of look at how that's unfolding.
Wow. Phenomenal what we can tell from rocks.
Yeah.
Camille, elaborate on your research and how you think it'll impact our knowledge and sustainability of the ocean.
Yeah, while Sarah is studying the very deep parts of the ocean, I'm right at the coast. I've been working in the Kelp Forest right off the coast of San Diego here. That's what's pictured in my background. And along the coast, there's been about 50 marine protected areas established in Southern California to try and ensure the persistence and resiliency of these really diverse ecosystems. But these MPAs are on the scale of kilometers in size. So how do we monitor them? Marine protected areas are areas where there's no fishing allowed. There's no one's allowed to take the resources out of that area. And if we're gonna put those restrictions there, we better know that they're working to help preserve this habitat. So right now, the primary method of doing that is scuba diving surveys, where people get in the water and they swim around and they count the number of fish and look at what's there and report back. But if you've noticed the weather lately, scuba diving is not exactly possible all times of year, right? You need good weather, you need really talented people to do this because you have to ID things in real time. And the biggest thing is fish are actually scared of us underwater. They change their behavior when we're there. And so if we're trying to monitor these areas, we should try to do it non-invasively because that's kind of the point of establishing protections. But what's fascinating about all these animals underwater is a lot of them use sound. A lot of them produce sound. It's not just the dolphins and whales that produce sound, but it's the fish, it's the invertebrates. They actually produce sound not only to communicate, but sometimes it's as a byproduct of swimming or feeding. And if we can identify who is producing which sound, all we have to do is sit down there and listen, and we know who's in the environment at all times. An acoustic recorder can sit on the bottom for years and just listen and tell you who has been coming through this area. But before we get to being able to just listen, we need to answer that question of who. And that's what I've been trying to tackle with my research. I built an underwater camera system and paired it with an underwater acoustic system so that when I listen and hear the fish, I can triangulate where that sound is coming from. And if I know where that sound is coming from and it's in front of the camera, I can now say that this fish made this sound. And we can start building up this library of fish sounds so that one day in these marine protected areas, we can just put down acoustics and listen and know which species are there and how many are there of those individuals. So it's a really interesting technique that it's a promising method, and there's a lot of challenges. You can imagine trying to figure out where something is originating from underwater is very difficult. Sound underwater travels much further than sound does in air. And so you can hear stuff from kilometers away. For example, in the Marianas Trench, which is the deepest parts in the oceans, we can hear sounds from the surface, and we can hear sounds from miles and miles away. So in our coastal environments, you hear the small boats passing by. So when you're going to fish out on the coast, the fish can hear that going by. They can hear their neighbors. They can hear their predators approaching. They can hear their prey. And so using that kind of soundscape to understand more about our ocean is a really promising method to non-invasively monitor it.
Wow. You explained that so well. I understood the whole thing. That's the real key to success. Laura, tell us more about your research and how you hope it will impact the future of our ocean.
Oh, now I have to follow Camille's great example.
She really did great.
Well, thank you, Val. And as you alluded to already, Val, I study zooplankton off California. So you probably everyone's heard something about plankton. Maybe you've seen SpongeBob and Copepod. He's a little plankton. And so I'm looking at the whole zooplankton community, the little animal, tiny organisms that drift around. And I'm looking at how that community changes off California during El Niño events. So if you're from California, or if you've paid any attention to the news in the last 20 years, you've probably heard something about El Niño. And you might think heavy rains and maybe big waves, but El Niño has significant impacts on the ocean and the communities in the ocean. And the most important thing to know about El Niño is that we're realizing that not every El Niño event is the same, and that different El Niño events can cause different changes to the ocean environment. So some of them bring really warm waters, some only bring somewhat warm waters, some of them change the ocean currents in one direction, and some will cause anomalous currents from another direction. And so we have this kind of variability between different events, and I call that natural experimentation that El Niño provides us, because we ourselves cannot induce experiments in the ocean. It's a little too big for that. So I use this El Niño variability to look at how the zooplankton community changes. And I'm really trying to understand how different parts of the zooplankton react during El Niño events, and kind of what specific parts of El Niño are causing those changes, so that we can make future predictions. And you might think, okay, maybe I've heard of zooplankton, but I don't really care about them. But you should. And the reason why is that everything else in the ocean depends on zooplankton. So you've probably heard that blue whales, the biggest animals in the world, eat exclusively krill, the tiny little shrimp-like crustaceans. But blue whales aren't the only ones. Many species of whales eat them, seabirds eat them, forage fishes, so like sardines and anchovies, and then everything else eats those. So really everything above zooplankton depends on zooplankton. And the other most important thing about my research is that not all zooplankton are equal, and some are more nutritious, some are favorable prey, and others are not so good. So during El Niño events, you might have this big change in the zooplankton community, and the whales might not be so happy, or they'll go feed in a different direction or a different place. And then you start to have problems with ship traffic running into whales because the whales are suddenly in a new place, or crab fishermen are setting their crab pots, but the whales are trying to eat there and getting all entangled. So changes in whale and seabird foraging and in the fisheries that we depend on can start to interact negatively with our human behavior. So if we understand the zooplankton and how they're changing, then we can better predict how these higher trophic levels, these whales and seabirds, might change during El Nino, and then we can modify our behaviors and kind of get humans out of the way where necessary. And as Zavala mentioned, oh yeah.
Do you need to wait for an El Nino event, or can your research progress without having a Nino event currently in effect?
This is a great question. So we want to study zooplankton during El Nino, but we want to compare them to non-El Nino years. And what my research depends on is this 70-year time series, a very long time series of zooplankton data off California. And it's run by a program called the California Cooperative Oceanic Fisheries Investigations. It was started in around 1950. And they go out to sea, let's see, on boats like this. This is the Sally Ride. And so this program goes out to sea several times a year, and they use plankton nets to sample zooplankton, and they measure the physical properties of the water. So I can draw upon that time series and examine.
So there's always work to do. It's not like suddenly that you have to wait for El Nino to come, going to progress and to advance the research. That's great.
That's right.
Sarah, tell us a little bit, what was one of the more exciting days? Because all of you have been at sea, right? And I think sometimes together, was that right? You've all been on one cruise? So tell us a little bit, about the, perhaps, like, what is it really like to be out on a boat? And I'm sure it's totally different than when you're in the lab. And was there a memorable moment, a day, a dangerous, exciting, some special time that you really remember?
Yeah, I guess there's two different things, because a regular day probably isn't your most exciting day. I actually, before I came here, I've never really been an ocean person, in the sense that I didn't see the ocean until I was 18. I'm kind of different.
What? Where are you from?
I'm from Idaho originally, and I think similar kind of experience.
No, Idaho.
But yeah, so I came here and I knew I was going to go to sea for 35 days, but I didn't even know if I got boat sick or not. So it's seasick. So I took a lot of medications, and it's a really cool experience. They'll fly you to wherever the boat is. And in my case, it was Easter Island. So I got to go spend a few days on Easter Island, and then they take you out on a smaller boat to a bigger boat, and you end up in this bunk bed room where you're sharing with 2 to 4 other people. You're on these weird shifts. I did midnight to 4 a.m. every day and 12 to 4 p.m. every day. So I would be up till 4 a.m. I'd go to sleep, and then I'd wake up and everybody would already be up eating lunch, and that's my breakfast. And so you just do, and it's 24/7. You just do there's these machines running constantly behind you. So they have screens everywhere. You can see what's happening under the water. At the same time, I'm trying to process magnetic data and bathymetric data, so we know where we want to put this machine next. It was just 24/7 operation. So it was really an interesting thing. But I do want to say my best experience was probably on the cruise that Camille was on. We were dredging. So that's, you don't get to have all these machines and see. You're essentially taking a big metal basket and dragging it across the bottom of the ocean and hope you grab some rocks when you pick it back up. And so we were dredging, and a couple people had said, we drove this whole way. We're 500 miles off the coast, and we're probably just not going to get any rocks or anything. So the 2 other chief scientists, Carrie McIntosh and I, were on board, and we had talked about what would happen if we didn't get anything. And it was 4 a.m. The dredge is coming up, and the first thing that shows up is the dredge is completely full with 100 pounds of rocks. And Carrie and I hugged each other. I might have teared up a little bit. And somebody turned to me and said, "Nice job, chief scientist." And I think that was probably, the pinnacle of my research career there.
Who would ever have thought a basket of rocks would make you cry?
You get excited.
Oh, by the way, I thought say somebody texted and said they wondered where you were from in Idaho because they are from Post Falls.
Oh, Post Falls. I'm from Boise, but Post Falls is very pretty.
Very good. So someone says hi. You can chat later, maybe. Camille, your particularly memorable experience when you were on board a ship or boat?
Yeah, the cruise that I went on with Sarah was, definitely exciting. That moment of people telling us we'll get no rocks, and then I think we ended up with like 2 tons of rocks. Like, we had too many rocks, and some of them are sitting in the parking lot because we still don't know what to do with them. So that was definitely exciting. I've been on a wide variety of cruises. The first really long cruise was part of a program called Sea Semester, which is for high school students and undergrad students. And it's, you spend 5 weeks on shore in Woods Hole, Massachusetts, learning about ocean sciences. And then you spend 5 to 7 weeks on a research sailing, so different than the boats that Laura was on and Sarah and I were on. It's actually it's a sail ship, and we do science aboard. And you're not only the scientists aboard, but also the crew on board. So they block out the GPS and they tell you to navigate by the stars. We had to get from San Diego to Tahiti over 7 weeks. So we're not only doing science, and you have to figure out how to stop a sail ship to do science in a certain location, but you have to make sure the boat goes and runs and operates. So that was an enormous amount of fun. I really loved going out in the middle Pacific, no internet, no email. I think going to sea is a really different sort of lifestyle. I like that there's less internet and that it's a really regimented schedule, and you're told when to get up and when to go to sleep and when to eat, to a certain extent, because I don't have to think. It's like my day is planned, and then I just do some things in between. And for me, I'm actually super productive out there. But I think the funnest part about being to sea is the people you get to work with. And all the people I've been to sea with have been fantastic. And I kind of use it as a barometer of people you want to spend time with in the future, right? If you're terrible at sea, I don't really want to spend that much time with you on land. It just seems to be a nice correlation between people who you just kind of find a way to deal, right? A lot of people get seasick, and a lot of people can have a rough time, but the people that succeed are the ones who just kind of work through it. You find a way to just manage through it, because for some people, going to sea is a once in a lifetime experience. We're really lucky that we've gotten to go multiple times, but every time I step on board, I try to think, okay, this might be the last time I go to sea. Like, wow, what things can I experience out here that I wouldn't be able to otherwise? And seeing the sunrise over the Pacific, right, and seeing stars and planets that you would never see out on land it's mesmerizing. It's like never a dull moment. There's always something to do. There's always something to discover.
Wow, navigating by the stars, that's fantastic. What an amazing experience. Laura, your experiences at sea.
Oh, well, Camille summarized a lot of them beautifully. I also did a sea semester trip, actually a couple, and that was really what sold me. And I will echo her sentiment that being out at sea really reveals people's characters. And I think I wish it were an experience that everyone could have, because I think it teaches you so much about yourself and how you respond in high stress situations. And it teaches you about teamwork and really having to work with people you might not get along with, and work with people kindly at 2 a.m. and to really pull your weight. And if you slack off, people are going to notice, and they're not going to be very happy. So I think sea is a really incredible personal growth experience. And definitely some of the most memorable experiences I've had involve rougher weather. This picture here is obviously a very flat, calm day off San Diego and a beautiful sunset coming up. But I've been in some pretty gnarly squalls, and you have to keep working as you can, even in the middle of the night when it can be very dark out on deck, completely dark, and the ship's deck can be tilted quite steeply sometimes, or rocking or moving around. So you really have to slow down and think about safety and think about your shipmates, and then just keep trying to do as much as you can. And as Camille mentioned, I've seen some just incredible things out at sea. I've seen school of yellowfin tunas breaching out of the water during an El Nino event because the water was so warm that they were just trying to escape and cool off, basically. And we caught one of the yellowfin tunas, and it was over 150 pounds, which is huge for a yellowfin tuna. That was pretty amazing. And there have been a lot of really cool zooplankton sightings too. So sometimes there are these gelatinous zooplankton called pyrosomes, and when you catch them, they look like these long pink tubes. They're a little bit squishy. They're kind of these cylindrical things, but at night they'll flash blue, they'll bioluminesce, and pyrosome is actually Greek for fire body, pyro, fire. And so they're flashing these little fires, and I've sailed through just oceans that were completely covered at the surface with flashing pyrosomes. So you're like sailing through this blue glow. It's pretty amazing.
Oh, how fabulous. You know, it's so funny. Maybe all us unmarried, not us, all you young unmarried ladies out there, before you say yes to the guy who wants to marry you, sounds like you should both go on some kind of ship or cruise and test their mettle, then find out what they're really about. Let's see. There's so many questions. What first got you interested in oceanography? Because Sarah, you're from Idaho. Laura, where are you from?
I'm from Sacramento, so it's a little bit landlocked, but I did go to the sea growing up, and what got me into it was you can't see the other side. I just wanted to keep sailing and studying it.
Yeah. Well, and Camille, where are you from?
I'm from Toronto, Canada.
Okay, so that's kind of, and so I'm sorry, I kind of cut Laura off. So yeah, so we have Toronto, Canada, Idaho, and Sacramento. And yeah, what was like the event, the experience that just captured your attention and drew you toward the ocean? I'm sorry, Laura, go ahead and elaborate. I didn't.
No, that's okay. It's my favorite question, so I always just segue right into it. But I just remember going to the beach with my parents when I was a kid and looking out at the ocean and saying, wow, you can't see the other side. And I want to just sail and go until I find the other side. And that's kind of been reflected in my desire to study it, because science, and I think, oceanography is just, it's a daily pursuit of new knowledge. You wake up every day and there's always something new to learn and to work on. And there's really never a dull moment. You're always pursuing some new path. Sometimes it's frustrating to figure out your path, but there's always something new to work on. And I think the thing I always tell people is you can actually have a career as an oceanographer or as a marine biologist or as someone who works on ships. And I think a lot of people will tell me, oh, I wanted to be a marine biologist, but I didn't know you could actually do that. And so Sarah and Camille and I are here to tell you that you can actually do these things.
Camille, what was the moment when you said, I think it's going to be oceanography?
I came home one day when I was 7 and told my parents that I was going to be a marine biologist.
What?
So since I was 7, I've pretty much stuck to this. And I had never seen the ocean, and I came home and told them that. And then at 13, we do a career exploration thing, and I discovered Scripps as a school and told my parents I was going to do my PhD here. So for me, this has been a long time coming.
Isn't that interesting? When we're that young, something just speaks to us that deeply.
Yeah. I think it's the idea that the ocean comprises all of the sciences. For me, I have a really hard time picking something that I'm interested in, because I'm interested in anything science related. And the ocean combines biology, physics, chemistry, engineering, math, everything you can think of. People of that background study the ocean. And so there are people like Sarah, who has a background in earth science, Laura has a background in biology, I have marine bio and physics, and there's some in biochemistry, all over the map. And so there's so many questions that you can address from different points of view that for me, it's like I have a never ending list of things I want to study, and they all make me happy. And so why not study the ocean, right? And I like the idea that almost every day I discover something new that no one else knows about. It's not only science, but it's also discovery, right? I have the data set that I have, no one else has in the world. And so if I scroll through it, I can find a new sound that no one's ever recorded, for example.
Wow.
And so that idea of combining science and discovery all in a system that kind of seems very foreign, right? It's like we're not meant to live out on the ocean, but that's the place that I'm the happiest. I am the happiest when I'm in the ocean, scuba diving, or if I'm on the ocean. That's like my happy place. And so, yeah, as Laura said, there's a lot of different careers. We happen to be PhD students, but we work with people with all different educations as well, right? To make a ship work, it requires a multitude of individuals. You've got the actual crew on board, so the captains, the mates, who are just making sure we get from point A to point B, right? There are cooks on board. That's a great thing about going to sea is you don't have to cook for yourself. I will mention that. And the food is fantastic. But then there's also the people who run the instruments every day. So there's people who that's their job is to run the instrument like that Sarah's showing. That's what they do every day. They go and get rocks from the bottom of the ocean, or they go and put instruments in the water. And then there's also the scientists on board who are doing the science. So there's jobs at every career level, and that's what makes studying the ocean exciting.
And that's important because, you know, you guys are all PhDs and that's beyond my ability as well. And yet you do not have to be PhD oriented. There's all opportunities, all levels, all skills, all everything. So oceanography, like you said, encompasses so much. So if you're young and thinking about it, don't say, well, I don't know if I can handle a PhD or I can earn that. Don't worry. There is so much involved in so many opportunities in different areas. So.
And I'll say, not even just if you're young, even if you're older, there are a ton of people who are much older in our PhD class who've completely changed careers. They've had an entire life, they've had an entire career path and decided, whoa, actually, I really love the ocean still, let me come in and study. So it's open to everyone, from the youngest of people who like can walk along the seashore and discover something to even our oldest of people who are discovering new things every day. So
terrific. Sarah, what was the moment you knew?
I think I'm different than our other panelists in the sense that I didn't really know until I was looking at master's degrees. So I had done my undergrad in physics and astronomy, but it turns out when you do astronomy, you don't get to go to the stars. So I was pretty disappointed. And it was cold and I was in front of a computer all day and I didn't want to do that. So I said, the next thing I want to do, I want to be somewhere sunny and I want to work outside and I don't want to do computers anymore. And I got half of that right, where I ended up getting this opportunity. I was one day away from doing a master's in forestry and I got a call from somebody at Hawaii and they say, hey, do you want to go work in Hawaii and do plate tectonic reconstructions? And I heard Hawaii and I said, yeah, that sounds great. Let's do that. And in some ways the plate tectonics was an afterthought. So I was, you know, having a STEM background really helped me there. And you can transition to pretty much anything that you want to try and do in engineering, and especially, I think engineering would have been better, but the math background really helped me there. But once I got there, it was so interesting to me. Like I've said before, I think plate tectonics is just such a cool thing that's really so recent. And the ocean is our final frontier in a lot of ways, right? We've been to the highest peaks. We've mapped everywhere on land that there pretty much is to map. We can see it on satellites. But the ocean is just such a huge mystery, and there's new places that you can go every time. Like you just a half mile off of where a previous cruise had gone, there's a whole nother world that you can see and experience. So I think it's one of the coolest things that you can do, and I'm really excited that I found it so late, but it was such a cool experience to have. And yeah. That's how I found it. And I will kind of parrot what other people have said in terms of, you don't need to have the science and background necessarily. Some of the people that were on our ship were actually known for their social media. They had gone and, you know, people are looking for ways to visualize the science that we're doing. And it's really important to have that photography background, somebody that knows how to make these figures come alive. And because if we are not communicating the science, what's the point of what we're doing in a lot of ways? So I think there's a lot of ways to get out to sea, to learn these things. We're always looking for that kind of outreach too.
Yeah, I was gonna say one of my favorite programs is the Artists at Sea program, where they actually bring artists at sea and they do their art at sea. Some of the stuff that comes out of that is incredible.
Oh my God, that would be amazing. See, everybody has a place in the ocean.
Yeah.
It's also kind of frightening. We hear about the ocean's health is really being tested right now. It's not in good health. Corals are dying. Tremendous amount of plastic. Obviously temperatures are changing. It's absorbed all the possible CO2s it can. We've totally saturated. So it's like, oh no, what's happening to our oceans? And it's kind of frightening because they're the essence of life. It's where life began, and it depends. So what is, with all the frightening, forecasts and problems in the oceans, do you think, do we have hope? Will we be able to save our oceans? Are there solutions out there? That's a big one I'll toss that up for anybody. That's a tough one.
I think awareness is key. Like these kind of outreach events that hopefully are reaching people over time. We need people to be aware that the ocean isn't just this entity that can take all the hits that we're giving it. We're making changes that are visible now. And I think bringing that attention to the ocean is one of the most important things that we can do as scientists right now.
One of the things is that January 1st was the start of the UN Ocean Decade. And so this next decade is dedicated not only to the studying of the ocean, but making it a place that's accessible to all. So I think, yes, there is hope. We've seen things recover, but we need to act now before it's too late. The ocean is essential to our way of life. You might have heard that every second breath that you take is from phytoplankton producing oxygen in the ocean. Our oceans are one of the major absorbers of carbon dioxide. And that's what's causing them to increase in acidity and causing, for example, the corals to die off. So the oceans play a really important role in moderating our climate and ensuring our way of life. Billions of people rely on the fisheries as their source of protein. The ocean is kind of this, it seems like this foreign place that we've been neglecting for years, and we've been trying to go to space all this time. But it turns out we should have been studying what was in our own backyard. So I would say don't lose hope and do the little things, right? There's little things like don't try to reduce the amount of plastic that you use, using a reusable water bottle, for example. Doing the little things can help drive to bigger change. And so don't think you have to reimagine your entire lifestyle necessarily. Take it one step at a time. I see a lot of people setting goals for the year. So reducing their plastic and just doing little things like that can make sure that there's an ocean for our future, and that our careers are not a dead end at the end of for us, that other people in the future will be able to continue.
Now, your thoughts, Laura, on the challenges that the ocean's facing?
Yeah, well, to piggyback on what Camille said, there are so many ways to get involved with helping the ocean. I mean, probably everyone's heard about 1 million ocean cleanup efforts, and sometimes it's like, why is one more person starting one more, plastic cleanup? But I think the hope for me is that probably even in the last 10 or 15 years since I've started studying the ocean, I've seen so much increased attention on ocean problems and what we can do about it, as both Sarah and Camille have mentioned. And I just think more and more of that attention from all angles and all across the world is really what it takes this groundswell of effort, and countries all over the world are working to clean up plastics. They're working to reduce plastics because they don't want them to get in the oceans. Their efforts in all major fisheries to combat illegal fishing and to implement sustainable fishing. I just saw a great documentary about Cambodian small-scale fishermen. So there's so much attention on it, and I think we need to just keep, facing the problems head on and talking about them and acknowledging that they exist, but also emphasizing what we can do. And a really cool example, since I have Sally right behind me, I never remember which way to go, is that Scripps is actually working on an effort to convert our ship fleet to hydrogen powered ships into the future, because one of the ironies of our work is that, we're out here trying to study the ocean so we can save it or preserve it, but we are contributing carbon dioxide emissions by going out to sea. So reflecting on everything we do and how we can sort of mitigate that or change our behaviors and our tools is really, it all ties together. And even if you don't become an oceanographer, you can always, as Camille and Sarah said, you can always do things either just for yourself, or you can get involved locally or on the side. And so many people come to me and say, I love what you do and I love the ocean and I'm so glad you're saving it for us. And I say, first of all, I'm not saving it, we're all saving the ocean together. And really by saving it, we're getting ourselves out of the way. And second of all, if you love something, you're going to take care of it. So keep that love for the ocean at the forefront of your mind, and do everything you can to think of it as a living, breathing thing, and then you'll take care of it.
Plastic is probably the thing that most people understand about the ocean because it's something that is very accessible. And so Mary Watson is asking, what is the major, and you may, if you guys aren't experts on plastic in the ocean, fine, you don't have to say, you can just say, sorry, don't know that. But she asked, what is the major source of plastic that is polluting the ocean? And where does it come from? And have you seen any evidence of it? I know, by the way, there are documentaries that look at nothing but the plastic problem, and I'm sure they have a lot of answers to these questions as well. But offhand, have you had any experience with plastic per se, or knowledge about plastic as a problem in the ocean?
Yeah, I can start. One of my former lab mates, she studied microplastics and nanoplastics, so the very small broken down plastic pieces. And many other people have also studied plastics. And one of the big conclusions that they draw is that so much of the plastic in the ocean comes from land. It's being washed off land sources. So that's why it's imperative that we clean our riverways and our beaches and reduce that trash flow to the ocean. Because once big plastic gets into the ocean, then it breaks down into these smaller and smaller pieces, and they're really hard to clean up.
So is it just coming like in the LA area? It's just coming down the washes, down like Bayonne Creek or in San Diego? I'm not sure what. So it's just literally stuff that doesn't get recycled, doesn't get in a landfill, ends up in the gutters, and then got into the sewer and water systems. Not sewer systems, that's different. It's just literally stuff that's on the side of the road and whatnot eventually gets.
Yeah, especially during big rain events like we're having now, things just wash into the ocean. And it's sad, there's so much by now that during big wave events, you can walk on the beach and see all this plastic wash back up from the ocean, plastic that's been swirling around for a while and then come back onto land. But it's not, oh, sorry, go ahead.
It's not like it travels miles and miles away. It shows up on the shores of Indonesia. I understand they have, is that right? It just like, well.
Yeah, plastics coming to your shores can come from thousands of miles away, and they really speak to how much the ocean moves around. And so it's no longer a local problem. It's an ocean-wide and human-wide problem.
God, it's incredible. Let's see. Oh, what challenges have you faced in your education or career paths, and how did you was there a big challenge, a moment when you thought, I don't know if I should do this, I don't know if I can do this, or someone was really a jerk, or you really had just to power through it? Any moments like that for any of you? I'll just open it up. Or was it smooth sailing?
I'll start, I guess. I think Yeah, there's challenging people everywhere, and I definitely should have taken my own advice of bringing them all to sea and testing them all out before working with them. I think the challenges are day-to-day little things. Sometimes it's really, you work all day on something and it doesn't work. And those little setbacks can add up. And so I think part of at least a PhD program is kind of learning to persevere through those setbacks, and learning how to push through. I have to keep in mind, like, I've wanted to be at Scripps since I was 13. And sometimes I have to walk that far back to get some perspective. It's not easy. And so keeping a good group of friends around and people who make you happy, but also finding other things to do besides always being immersed in the ocean can be a great thing. San Diego is a lot of fun to be in generally when we're not in lockdown. And so exploring other avenues and other interests helps to persevere. But I would definitely say, I think I've now taken the approach of testing the people out first before asking about the research, of trying to avoid the prickly folks in life that exist everywhere. And to some extent, you can't avoid some of them because it's just they're along your path. But knowing that your self-worth is not reflective of their personality, and that you have a spot here is an important, it's like you got to keep the big picture in mind.
Good. Great advice. Great advice. Any other thoughts on that? Problems, setbacks, challenges?
Yeah, it's kind of interesting. I mean, we're in our 6th year, so I think we've overcome a lot that maybe other people didn't quite overcome. Not everybody finishes grad school.
That's
So
right.
yeah, so I think it's really interesting. I've been really blessed with the advisors that I've had and the mentors that I've had, but I've seen it go other ways. And I think overall, generationally, we're really improving for women in science. I can speak to women in sciences, I guess, but I think we're improving a lot. But it is one of those things where I think we're really benefiting from previous generations and the work that they've done, but we can always be improving. And especially to increase our minority outreach and increasing the number of women that are staying in science, I guess would be the way to put it. We need to keep the women that are finishing the PhDs in science. And I think one of the most important things that I've learned, like Camille said, it's your cohort, it's the people that are with you every day. And I think what we learn is that it's really important to prop each other up and help each other. One of the minor things that I think is really important is, especially with a generational thing that we have here, you'll sometimes get interrupted, and it'll be with the same thing that you said. And one thing that I think really has benefited is having other women in the room being like, oh yeah, X said that. I think we really need to start focusing on supporting each other and making sure that we're always heard and recognized for what we do.
I'm going to mute for a second because my dog is barking at a dog that's walking by. But Laura, are your thoughts on that?
Yeah, I mean, I just second everything Camille and Sarah said. And I think particular, adding on to what Camille said, that result in our field of long-term scientific research, and I think in many walks of life, results don't always come overnight. We talk about how we love our jobs and we're excited every day to, to learn something new and discover something, but there are a lot of hard grind moments, and you go down one path for a while and it turns out it's not the right path, or it's not leading you where you want to go, or maybe it's a step, but you need to take 5 more steps, and even after you thought you should be done. And so persevering and coming back to, the larger picture of what you're trying to accomplish, and having patience and remembering that things that are important take time and they're not going to happen all at once. And sometimes they need someone coming back and pushing them again and again and again. And the other, as we've mentioned multiple times, just learning to work with people from other backgrounds and walks of life and other viewpoints that you won't always agree with. I think that's a lesson we could all learn more of.
So true.
Always
Here's
hard,
a question Question from Kathy Johnson. She says, as a teacher for decades, I hear students say they want to be oceanographers. I was once a biology major, so I've directed them to start there. How should I advise them? It sounds like you don't have to go the biology route necessarily anymore. Is that right?
Yeah, I would say actually, I think the most successful students in oceanography are those who have a solid foundation in mathematics, and even more so now in coding. We are now in the big data world where we have millions and millions of data points. It's no longer we collect 3 samples, for example, we could collect thousands. And so while biology seems like a really easy entry point, because most of us love big animals, we love our whales, we love our dolphins, we love the cuddly things. Oceanography, there are people who study how the currents move. So we were talking about plastic and how it ends up somewhere else. People model that and try to figure out how those currents move. There's people who study the interactions between those currents and the climate. So even climate sciences falls under oceanography as well. There are people who study the chemical makeup of the ocean and what kind of nutrients are there. So it's all across the scientific disciplines. So if you're interested in oceanography, my suggestion would be, think of which of the basic sciences most interests you. Is it biology? Is it chemistry? Is it physics? Is it mathematics, engineering, right? Someone has to build all these tools. And start there. You don't have to major in oceanography. You don't have to major in marine biology. It's almost a disadvantage to get such a closed view of the world to start with. Start with something broad and take some ocean classes and kind of mix it in. But make sure that you're able to understand the language of science, which is math and coding now. So those skills are really important, and the ones that I've personally seen. Students with those skills can do anything. There's also there's genetics labs that do oceanography. There's drug discovery in the ocean. So a lot of potential cancer drugs come from ocean things. So if you're more interested in the cell biology genetic space, get some training in that. But think of it as a kind of a skill set of what you want to do and keeping it broad. Like as Sarah said, she had a degree in physics and astronomy and transitioned into oceanography. So yeah, you don't have to start off with studying the ocean. Start off with something that you love.
Now here's a couple of questions. I want to get these couple questions in here. Lucia says, I love that it's 3 women PhD candidates. What is the size of your class and what is the gender and ethnic makeup? That's just a real quick answer. And then there's another question after that.
Well, we were the first majority women class. I think there were 50 students coming in, and I do not know about what the diversity of those, of the background of those students. But
how many in your cohort altogether?
50, I believe.
50,
and
wow.
So over 50% of those were women. I don't know the exact statistic.
Really?
And the number of women, I think women have been the majority of incoming classes for most of the past years.
Wow, that's great. That's interesting.
So it's definitely increasing, and geosciences is often considered one of the least diverse sciences, but people are actively working in to recruit those of minority. So I want to say, no matter what your background is, there's a place for you here, even if you don't see someone who looks like you. You can be that difference person. And as I think Laura said earlier, we love talking to people with different experiences and different viewpoints, because that's how we get better, do better science. That's how we get different perspectives, and it leads to innovation. So it's really important that it's not just us here, it's people of all different backgrounds.
That's true. And Mary in the audience says, just good information, the American Association of University Women, AAUW, has a program that takes high school girls interested in science to science camps at local universities. Is there a tech trek camp I wonder if Scripps has this. Is there a tech trek camp at Scripps? Now, you may or may not know, it's okay if you don't. But people should make note, the American Association of University Women has a program that takes high school girls interested in science to science camps. So that's fantastic. And let's see, we have 6 more minutes. Just real quickly, what do you think your research will accomplish, or what do you think it will contribute to? You know, it's because research is very fine and it contributes something larger. But what do you, and the other thing is, do you expect to change course in your research? Will it get finished, or is this it for the rest of your career? How does that work?
I just want to circle back real quick because I feel like the logistics, especially for young people that are watching this, I want to make sure that they know. I do think we have something similar, not tech-wise, but like we have a surf student program here at Scripps that has undergraduates come to work on specific project with people like us, graduate students that need extra hands. And I think those are great ways to get into oceanography. If you're just an undergraduate and you're interested, those are the kind of projects that I think would really work for students. And it's kind of surprising, but like cold calling, I actually got interested in Scripps by emailing 2 or 3 professors just randomly. I said, I really like your research. I think that's a way to go. And I think that's some ways that students can actually kind of get into oceanography and learn what's going on. Because a lot of students, professors might be like, oh, I don't have a project, but here's something like the surf project where you could come to work and get paid to work as an undergraduate. But in terms of,
yeah, where do you think your research is going, and where do you think you're going in terms of your research?
Yeah, I think our paths change over time. I know I was always interested in continuing on to academia and keeping working in science. And I think I'll always work in science, but I think there's so many opportunities outside of it, especially now. It's important to communicate science and look towards policy making and what we could be doing. So I think careers in places like NOAA and USGS are really important.
Yes. We need you guys. We need you guys helping make policy too. People who appreciate and understand science. Your thoughts about
I really want to
take you?
Yeah, I really want to keep developing low-cost tools to increase the accessibility of oceanography so that we can literally populate the ocean with instruments to be able to monitor it 24/7. That's something I'm really passionate about, is essentially using what we call the maker revolution. So all these little mini computers and all this off-the-shelf tech stuff to be able to use that and study our oceans. And right now I'm really interested in becoming a professor, not only because I really enjoy this research track, but I really enjoy mentoring students and training the next generation. And I think I learn the most from working with them. So that's something I want to continue.
Oh, nice. You'd be really great at that. Laura, your future.
I love what I do. I love the research I do, and I would love to keep doing it. I think really working to inform fisheries, fish stock management is something I see as really important, and that my work can contribute to. And across multiple ocean systems and multiple parts of the world, I mean, I would love to live, 5 or 10 different places. And oceanography can really help you do things like that. So definitely continuing on that track, and also just teaching, bringing people out to sea, teaching people about the ocean, helping people learn about science, even if they don't think they want to be scientists. The scientific process can teach you so much about being a deeper thinker. So I would love to give back more teaching and mentoring on that.
Yeah. And my advice would be is if you're out there and you don't have to take on a big, huge trip. You can just dip your toe in the ocean. You can take a trip to Catalina, get on a boat, so easy, and you get the sense of the boat and the ocean. And there's great trips out to the Channel Islands. It doesn't have to be a big, huge deal. It can be a day trip or a weekend trip. I was lucky enough, I got a big trip to the Galapagos, which was fantastic. So there's many, many ways to enjoy the sea and to introduce yourself to these great, great experiences. So I'm going to let our 12:59. Thank you, all of you. You were absolutely fantastic. One of the best we've had. They're all great. You guys just have a wonderful rapport, and the fact you all know each other really, really helps. So I can't thank you enough for taking time out of your busy lives to help shape some young people out there and to help keep our oceans healthy and alive, because we can't live without them, literally. So thank you, Camille, Sarah, and Laura. And for our audience, I would like to remind people that our next webinar, AltaSea webinar, is February 26th. I don't know what day of the week that is, February 26th, for a live chat. Join AltaSea for another Project Blue live chat. We will be joined by Dr. Clarissa Anderson. She's Executive Director of the Southern California Coastal Ocean Observing System at Scripps. I don't know if you know her. executive director. Her name is Clarissa Anderson, Dr. Clarissa Anderson. So join us for that. That is February 26th. Thank you all for being part of this. And if you want to share or watch it again, you can see a recording of this webinar at altasea.org. altasea.org. Thank you again, all of you, so much for your wonderful comments and your dedication and what you've given today to all these people who are watching. Thank you. Thank you. Take care now.
Well, thanks.
Thanks, everyone. Thanks, Altasea. Thanks, Val.
Thank you, guys. It's been great.
Bye. Take care.